and welcome to this episode of Night Sky News for September 2024 with me, astrophysicist Dr. Becky Smethurst. This is a show where we chat about what you should look out for in the night sky in the next few weeks, and then we chat about what's been happening in space news in the past few weeks. In this episode, there is so much to talk about. There was the successful lunar-Earth flyby of the JWST spacecraft on its way to Jupiter, the new hypothesis to explain the famously unexplained WOW signal, and a new explanation for JWST's impossible overmassive galaxies. There's chapter markers down here if you want to skip ahead to any specific news story, and any scientific research papers I mentioned are all going to be linked free to read down in the video description below. Thanks to my friends at Planet Wild for sponsoring this video, but more on them later, and without any further ado, let's kick things off and start by looking up. All right, let's start with everybody's favorite, the planets, and which of them we can actually see this month. So Mars, Jupiter, Uranus, Neptune, and Saturn are all visible throughout September and October. Now, Uranus and Neptune are too faint to just see with your eye alone. You are going to need either decent binoculars or a small telescope to be able to see them. But on the 22nd of September, Neptune does reach what's known as opposition, where it's in the exact opposite part of the sky from the sun, meaning you can draw a line essentially between the sun, Earth, and Neptune. That means that Neptune will be the brightest that it ever gets in the sky. So if you're going to break out your telescope to be able to see Neptune, this is the time to do it, especially considering the fact that when it's at opposition, it means that it will be visible all night as well. Similarly, Saturn just passed its opposition, so it's also very bright in the sky right now and also visible all month, all night long. You should be able to spot it thanks to that sort of yellowish glow that it does have. Also, because Saturn's axis is tilted like the Earth's axis is, it also has seasons, and it means that we also sort of see like phases of Saturn's rings as they sort of tilt towards us and then away from us again. And we're getting soon to the point where Saturn's rings will actually be edge on to us and you won't actually be able to see them for a while. So again, if you're thinking about breaking your telescope to see Saturn, see it now while you still can't actually see bits of the rings. And then as for Mars and Jupiter, they're going to rise in the east around about midnight and be visible until sunrise. And just like last month, the Crescent moon, aka the toenail moon, my favorite moon phase, can help you find Mars and Jupiter and act as a little bit of a way marker if you're not sure what you're looking for. So on the 23rd, the Crescent moon will be above Jupiter, between Jupiter and the Pleiades star cluster. And then on the 25th, it will be closest to the very bright Jupiter, the brightest of the planets visible at the minute. And by the 26th, closest to the reddish, fainter Mars. Again, if you've got binoculars, break them out because you should be able to fit both the moon and then either Mars or Jupiter in a single field of view of your binoculars at the same time, which is always really fun to do. While you're there, look out for the moons of Jupiter as well. That then takes us past the vernal equinox, which marks the official start date of autumn in the northern hemisphere and spring in the southern hemisphere. It's also when we have equal day and equal night thanks to the Earth's axis tilt, or as I like to think about it, equal time for exploring during the day and then stargazing at night. For us here in the northern hemisphere, it means that our nights are now going to get longer and longer than our days as the year goes on, which means more time that we can get under the stars. And one of those reasons to get under the stars might be to view a meteor shower. So that's a night when there'll be more shooting stars than normal. We've got 2 meteor showers in October. First up, the Draconids peaking on the 7th of October, and then the Orionids peaking on the 21st of October. Now, both of these meteor showers are caused by debris left behind by a comet on its orbit around the sun, that then the Earth passes through that debris field and all of it burns up in the Earth's atmosphere and causes these multiple shooting stars. And in the Orionids case, they're actually caused by the famous Halley's Comet. Now, you might see a lot of hype in the media in the next couple of weeks about these meteor showers, and I just want to manage expectations a little bit, because for meteor showers, you really do need a dark sky. If you're in the city, I wouldn't even bother trying to get set up outside to watch this, because the light pollution from the city is going to wash out the majority of meteors. You might see one if you're lucky. The other thing to consider is the moon, because again, if it is too bright, it's sort of a source of its own light pollution in the sky, and that too will wash out all but the brightest of meteors. So for the peak of the Draconids on the 7th, the moon will be a thin crescent, meaning it will set early, the sky will be nice and dark, but for the Draconids, there tends to only be maybe around about 10 meteors per hour at its peak, which only means one every 6 minutes or so, and one of those is probably going to be very faint as well, so you have to be very patient waiting around to even see a meteor. The Orionids, there's more like 20 meteors an hour, so on every 3 minutes. So you have a better chance there. But on the peak, on the 21st, the moon will be just past full, sadly ruining the show. So honestly, unless you're in a very rural, remote, maybe wild place, I wouldn't bother going out to try and spot either of these meteor showers this year. The conditions just aren't favourable. Speaking of the moon though, there's a lucky few in South America who will see an annular solar eclipse this month on the 2nd of October. So not annual as in once a year, but annular as in ring-shaped. Because the moon won't fully block the sun during this eclipse, you'll still see a ring of the sun's light around it. And that's because the moon's orbit isn't a perfect circle. It's oval shaped, and so the moon is actually going to be slightly closer to Earth when this eclipse happens. That's also why the full moon later in October will also be classed as a supermoon again, but it's also why the moon won't look quite the same size as the sun in the sky and won't fully block it, leaving that ring of light around the outside, an annular solar eclipse. I'll pop a link in the video description below where you can put your location in and find out what you'll be able to see at what time and whether it's a partial or a full eclipse for you. And a friendly reminder, do not look at the sun directly with your eyes, you will damage them. So I'll also put a link in the video description down below on how to safely view the eclipse as well. But the big thing to keep an eye out for this month is a comet, Comet C/2023 A3 Tsuchinshan-ATLAS, because it will definitely be the brightest comet of 2024, and there is a chance it could become visible with the naked eye, making it one of the brightest comets of the past few years. Now, us astronomers like to joke that comets are like cats. They have tails and they are completely unpredictable. So in terms of how bright this comet is going to get, it all depends on what happens as this comet makes its closest approach to the sun on its orbit, which will melt a lot of the ices, releasing all the debris that makes up a comet tail, and the more debris, the more light it will reflect, making it brighter. So it could end up being the most incredible thing that we've seen in the sky for years, or it could end up just fizzling out. We don't know yet, we just have to keep an eye on what it's doing. People are monitoring its brightness though, and things are looking promising. It seems to be tracking the prediction, so fingers crossed. Now, its closest past the sun as it loops around is going to be mid-October, so the best times to try and see this are either going to be before that in late September, early October, where you should look towards the east before sunrise and see if you can spot it, or if you're viewing it after its closest approach to the sun, so after the 13th of October, then you should look towards the west just after sunset for that telltale tale of a comet. I'll pop some links below for you to work out where in the sky it will be from your location on what date. Now, before we get to space news, I spoke before about how some of the best places to stargaze are wild places, immersed in nature and away from the light pollution of cities. But those wild places are at threat. And I don't know about anybody else, but I often feel really quite hopeless and helpless that there's just nothing I can do to help the environment. That was until I discovered Planet Wild. Planet Wild is a global community of people who care about the planet and are tired of talking and want to see some action. Every month, they team up with a new partner organization and go on a mission to bring back an endangered species, or clean up our oceans, or revive forests. They fund these missions through their monthly or yearly memberships, then document the process here on YouTube so we can see exactly where our contributions are going to. It's like crowdfunding for nature. You can support Planet Wild in so many different ways. You can get a membership like what I have, which has no fixed price. You can give as much as you're able to, big or small, and you can cancel at any time. But I'm sure you'll love it as much as I do. You can also support them by watching their project videos on YouTube. On their latest mission, they're helping to rewild some of America's farmland after decades of overhunting and unchecked agricultural expansion. Now they're reintroducing the iconic wildlife like bison that once roamed there. It's probably easy to see why I love Planet Wild so much, which is why I'm giving out a month's free membership on me to the first 200 people that sign up with my code DrBecky9. You can either scan the QR code up here or follow the link in the video description below. And the best part is you'll already make an impact within that first month, and you'll get to read the report of their next mission within the first 30 days. So if you want to learn more, I've linked their YouTube channel and the video of their latest mission below. So thanks again to my friends at Planet Wild, and now let's come back down to Earth and chat about what's been happening in space news in the past month. All right, first up, let's talk about Boeing's Starliner. If you remember from last month's episode, NASA astronauts Suni Williams and Butch Wilmore are still stuck aboard the International Space Station. They arrived on a Boeing Starliner on the 6th of June on its first crewed test flight, but during the flight, they reported problems with 5 thrusters and 5 helium leaks during the launch and the docking. Now, they were originally only supposed to be aboard the ISS for 8 days, but they've been there over 3 months now after NASA decided it wasn't safe for them to return to Earth on the Starliner and instead made the decision that they'd return on a SpaceX Crew Dragon mission that didn't return to Earth until February 2025. Now, in the end, the Starliner craft managed to safely return to Earth from the ISS on the 6th of September, albeit with no crew, but with no more issues with its thrusters either. It'll now go through even more post-flight analysis from Boeing and from NASA to figure out what went wrong. And it's worth saying here that NASA has reiterated its commitment to Boeing Starliner craft. They really don't want to be reliant on SpaceX alone. They want 2 US companies to be able to handle these launches of astronauts to the ISS. All right, next up, let's talk about ESA's JUICE mission to the icy moons of Jupiter. Because if you remember from July's Night Sky News episode, it was set to do a flyby of Earth on the 20th of August in the first ever lunar-Earth flyby, which was also set to be the first ever double gravity assist maneuver. The probe was launched back in April 2023, and through a series of flybys of Earth and Venus, will eventually gain enough energy to make it out to the Jupiter system by July 2031. Now, if you're thinking that sounds like an incredibly convoluted and weird way to get to Jupiter, why not just send it out on a straight line? Well, it's because it's a much more fuel-efficient way of doing this. So although this lunar-Earth flyby that was planned is an incredibly risky and complex maneuver, it would save the mission around 100 to 150 kilograms of fuel. And at the end of August, ESA reported that the maneuver was successful. Flight controllers guided the spacecraft first past the moon, then past Earth, and the gravity of the two changed JUICE's speed and direction. So the flyby of the moon actually increased JUICE's speed by 0.9 kilometers a second relative to the sun and put it on a trajectory towards Earth. And then that Earth flyby actually reduced JUICE's speed by 4.9 kilometers a second relative to the sun, putting it on a trajectory back towards the inner solar system, towards Venus, where it'll then do another flyby next year. So overall, this lunar-Earth double gravity assist maneuver that JUICE did changed its trajectory by 100 degrees. So an angle of 100 degrees, so like 90, right, is a right angle, so over a right angle in terms of the angle of its flight path. In the hours before and after both close approaches, JUICE's 2 monitoring cameras captured photos, giving us this sort of like bonus JUICE eye view of Earth and the moon. My personal favorite was this sort of last look back at the entire Earth-Moon system as it heads on its way to its next gravity assist flyby of Venus in August 2025. Once it arrives at the Jupiter system, its main mission is to investigate the properties of Jupiter's moons and work out if they are possibly habitable to life, that's either past life or current life in the Jupiter system. And speaking of life out there in the universe, we need to chat about the WOW signal. And this research that came out this week dashing the hopes of many by explaining it as just another run-of-the-mill astrophysical process. Now, if you're not familiar with the WOW signal, it was discovered back in August 1977 in data taken by Ohio State University's Big Ear radio telescope. Astronomer Jerry Emmon was actually looking at the data that the telescope had taken a few days later when he spotted this weird thing. He was so impressed by how weird and bright it was that he circled the computer printout of the reading of the signal's intensity, 6EQUJ5, and wrote the comment "wow" beside it, leading to the signal's colloquial name of the WOW signal. The signal appeared to come from the constellation of Sagittarius, and it had all of the features and the hallmarks that people suspected that any signal that came from sort of an intelligent civilization of extraterrestrial life out there might actually have and that people were on the lookout for. So it was very bright, and it also lasted for a really long time. It lasted for the full 72 seconds that the Big Ear could look at one specific part of the sky for, which meant that it was continuous. It wasn't like it was a brief random burst and then gone. And it was only detected in a very narrow wavelength range of 1420 megahertz, where hydrogen naturally emits light at anyway. So we've got telescopes that are already designed to look in that wavelength region to study the sky, to study gas in galaxies and things like that. So when we think, okay, well, if we were going to send a signal, we should send a signal in a wavelength range that we know an intelligent civilization will probably already have the tools and technology to pick up and be on the lookout for. Essentially, it was the beginning of the plot of the film Contact that was playing out in the late 70s. The problem is the WOW signal has never been detected again, despite many attempts with more powerful radio telescopes to try and spot it. And there's been many hypotheses raised over the years to try and explain it, like maybe it was extraterrestrial life, or maybe it was just a burst from a high energy object like a pulsar, or maybe even something from a comet. And then there's the more boring, like Earth-based explanations for this. So for example, it could be a signal that came from Earth but was reflected back down to Earth off a satellite or some space junk. Or maybe the telescope picked up some interference from satellite communications. Or maybe the bigger telescope just had a glitch. We just don't know, especially without detecting the signal again or more signals like it. We've just not that much data to go on. Which was a problem that Mendez, Ortiz-Ceballos, and Zuloaga decided to try and solve with the Arecibo WOW project. They've been searching through archive data from the Arecibo Observatory to try and find more signals that are like the WOW signal that have just been buried in the data all these years. If you remember, the 300-meter wide telescope at the Arecibo Observatory actually sustained damage from a few hurricanes, specifically Hurricane Maria in 2020, and by the end of that year had fully collapsed and was damaged beyond repair. So this is why this project is mostly an archive data project, but in 2023 they did manage to get some more data using the 12-meter telescope at Arecibo, focusing specifically on red dwarf stars with potentially habitable planets. And they did manage to find something in the archive data, taken back in 2020 in the direction of Teegarden star. They found 4 signals that looked similar to the WOW signal. Now, admittedly, they were ever so slightly fainter, but they were similar in all their other properties. But those signals didn't all align directly with Teegarden star. Instead, the regions around it, where there were known clouds of hydrogen in our galaxy, the Milky Way. So Mendez and collaborators suggested that these 4 signals, and also most likely the WOW signal, were caused when a cloud of hydrogen gas in our galaxy got hit by a big burst of energy that gave it enough energy so that it could briefly flare and shine with radio lights. Now you might ask, okay, well then what caused the big burst of energy that hit the hydrogen cloud of gas in the first place? Well, it's likely something that in itself is also just a brief event, like a flare from a magnetar, which is a type of pulsar with a really strong magnetic field, which doesn't repeat, right? It's a very brief flare and then it's gone. So as much as I imagine the whole internet was hoping that, the plot of Contact was actually going to play out and that the WOW signal was, from aliens or extraterrestrials, it seems like this explanation from Mendez and collaborators is the most comprehensive hypothesis that explains all the properties of the WOW signal and these additional ones found in archive Arecibo data. Again, if we can find more of these signals either in archival data or in new data that's taken, then that would definitely help flesh out this hypothesis even more, especially if one of those transient magnetar flares was detected around about the same time as well. In the meantime, if you want a deep dive on the WOW signal, David Kipping over at Cool Worlds has a great video on this, which I'll link in the video description down below. Finally, do you remember JWST's overmassive galaxies problem? I've covered it a few times on this channel and on Night Sky News before, and there's been many hypotheses raised to explain them so far, most of which involved either us underestimating or overestimating something in our calculations of what the actual mass of these galaxies were, which definitely didn't involve a breaking of the Big Bang Theory like the internet latched onto. And this month saw another research paper come out looking at this, but this time from Kurowski and collaborators, i.e. the official JWST Sears team themselves, who said that black holes are to blame. So first off, a quick recap. Back in March 2023, Labby and collaborators reported that they'd found 6 distant galaxies that were much brighter than expected. More light in a galaxy generally means more stars are needed to account for that light. So the galaxy is bigger and heavier essentially, and what we do is we fit models of how many stars there have to be that are there to account for the amount of light that we've seen. And when Labbé and collaborators did that for the 6 galaxies they found, using just the images from JWST, they found they were far more massive than expected for how distant they were. So because light takes time to travel to us, as we view distant galaxies, we're seeing them earlier in the universe's history. And so for these 6 galaxies, essentially what we're saying is the universe hadn't been around for long enough. There hadn't been enough time for them to have formed the amount of stars that they had managed or appeared to have formed, given what we know about gas collapse and how long it takes for stars to form in our best model of the universe that we have that incorporates all the known laws of physics. However, that calculation of their mass is fraught with pitfalls. First of all, to do that conversion of light to mass, you need to assume the spread of the amount of the different types of stars that you have. Like, how many heavier stars do you have compared to how many much lighter stars do you have? And what we usually do is assume that that is the same as what we see in the Milky Way, where we can actually count the relative numbers of the different types of stars. But the early universe is probably a very, very different place to the Milky Way is today, given the fact that it was much denser and hotter. And so just a few months later in 2023, another paper was released suggesting that this could all be accounted for if that spread of stars, known as the IMF, varied ever so slightly. Now, what Kurowski and collaborators are claiming is that not all the light that's being given off by these apparently overmassive galaxies is actually coming from stars in the galaxy. A lot of it is actually coming from the supermassive black holes at the center. As gas gets drawn into and around a black hole, it gets accelerated to huge speeds and so gets superheated so much that it glows. This is from the regions around the black hole. You've not crossed the event horizon yet, which is why we can actually see the light from this. And essentially, the more material you have around the black hole, the faster it's growing at, but also the more material there is there to glow, and the brighter it will be, and therefore the more light it will contribute to the apparent overall galaxy's light. And so this is what Kurowski and collaborators are claiming is happening here. Not all the light is coming from stars. Some of it's coming from the growing supermassive black hole in the center. And it was that light that was skewing the calculation of the mass and causing us to overestimate it. Now, because Kurowski and collaborators had access to the full Sears data, they could actually look at the estimated masses of all galaxies in their sample, not just these little red dot oddities that were found by Labbé and collaborators. And so with the full sample, they could work out, okay, well, is there actually a tendency for galaxies in the early universe to be more massive than they expect? And therefore, is there something wrong perhaps with our understanding of how stars form in the early universe perhaps? And what they found was that actually, no, there isn't a tendency for galaxies to be overmassive, but they did find more massive galaxies, i.e. a higher number of massive galaxies than you'd expect for that time period in the universe's history. There are roughly twice as many massive galaxies in JWST data than we'd expect from our model. So they're not overmassive. There isn't anything being broken here in terms of they've not had enough time to become that massive. They've had enough time, it's just that more of them have become that massive than we'd necessarily expect, which is really interesting. Again, this is evidence that the early universe is different than we perhaps thought, and perhaps basing on the universe around us today. It raises the question of, okay, can stars form more efficiently in the early universe because gas is denser? Or perhaps mergers of galaxies were more common with everything being a bit denser, growing more heavier galaxies so you have a higher number of massive galaxies. As usual, more follow-up work will help here, especially getting a spectra of as many of these galaxies that we can. A spectra is where you take the light from a galaxy and actually split it into its rainbow, its trace of, how much light of each wavelength you receive, which gives you so much more information about a galaxy. You can go much deeper into the analysis. It's just the problem is that data is much more expensive to take than an image. It takes a lot longer, and so you can't get it for as many galaxies to get that kind of level of detail that we need to try and work out what's going on here. But like all good science research papers, it might have answered one question, but it's raised a whole host of new ones. All right, that's it for Night Sky News for this month. Don't forget to check out the great rewilding work that Planet Wild is doing. I'll link some of their videos for you to check out in the end cards that will pop up during the bloopers. As always, if you spot any space news stories that you'd like me to explain in a future video, or if you snap any pictures of the night sky that you want to share, then send them my way over on social media. Until next time, everyone, though, happy stargazing. By looking up. I did a weird little eye thing there. Little burp there. Tsuchinshan. I presume that's how you pronounce Tsuchinshan. For that telltale tale of a comet. Telltale tale of a comet. That telltale tale. That sounded so cool when I wrote it down, but now I'm like, why did I write that line for myself? A telltale tale of a comet. So to find out more, I was desperate to finish that before I needed to go. July 2031. Flyby, I touched my light. Juiced did? It was juiced. Jerry Emin. Man? Astronomer Jerry man. Man. If I was a Geordie, that's how I'd say it. Man. Mendez, Ortiz Ceballos, and Zuluagas. Oh, jeez. Why are there so many names that I don't know how to pronounce in this video? Zuluaga. Just say it really quick, it'll be fine. Again, why are there so many names I can't pronounce? Chwarowski? I'm just butchering their names. Kurowski. Oh, that's not how I thought you'd pronounce it. And that light is what was. It answered what? Did I even talk about the black hole? Oh my god, I missed that whole bit. Sorry. I was like, wait a minute. That'll do, pig. That'll do. When did you flick off? Rude. Absolutely rude.